Hello, students. This is the background information you need to know in order to calculate pH. To do that, we need to know something about Kw. I will tell you about that in a minute. But first, how do we count the number of H plus or OH minuses in a solution? It is important to count it because we need to quantify how much of those ions are going to react to be able to do stoichiometry and predict reactions. Imagine this square as pure water. Imagine yourself holding a glass of pure water. If the temperature is 25 degrees Celsius, some of the water molecules will split apart. Okay, so here's the water molecule together. Here's the hydroxide, OH minus, that split from the H plus. And here's the drawing of the water splitting. Water will do this on its own. It is called auto-ionization, breaking apart on its own. Okay. If the temperature is 25 degrees, a very, very, very small amount will do that. Specifically, 1 times 10 to the negative 7 molar, or moles per liter, will come apart. If you think about it, that's really small, 0.0000001 molar, very small. Here, 1 times 10 to the negative 7. They have to match because they came from each other. Okay, so at this temperature, only a small amount will do that. If you multiply those two numbers, the molarity of this is 1 times 10 to the negative 7 at 25 degrees Celsius. The molarity of this hydroxide is also 1 times 10 to the negative 7 molar. You will get a number that is called Kw. That number is obviously 1 times 10 to the negative. You multiply these two numbers. Rules in math, when you multiply numbers, you add the exponents. So negative 7 plus negative 7 is negative 14. Kw. This is called Kw. It is called the ion product constant for water. It's product because you're multiplying two numbers. It's a constant because it will never change at this temperature. This right here is the amount of H plus, or the molarity of the H plus, right? If you look at the exponent, that is pretty much going to tell you the pH. This is pH 7 because of the power of 10. Okay? So eventually I will teach you what pH is and how it is calculated. And you can see already that it is based on the molarity of the H plus. To get the 7 out, we have to log the power, this 10, or the 10 to the negative 7. And now I'm going to teach you a little bit about logarithms. So logarithm is just pretty much the power of 10. Let's look at the number 1,000. Do you agree that 1,000 is 10 to the power of 3? Okay, so the logarithm of 1,000 is equal to 3. So if I say the logarithm of 1,000 is equal to 3, because the logarithm of 10 to the 3, which is the same as 1,000, is just the power of 10, which is 3. So if we take the logarithm of 1 times 10 to the negative 7, so H plus concentration is 1 times 10 to the negative 7, right? So if we take the logarithm of that, you guessed it, the answer is going to be negative 7. So you've wondered, well, pH here is positive 7, why is it negative 7 here? The reason is, to get rid of the negative 7, all you have to do is multiply this by negative 1, and you're going to get this to go away. So it is just the pH of 7. Okay, so to get the pH, all you have to do is take the negative log of whatever the H plus is. And this is how we get the pH. And you can see by knowing the pH, you can count how many H pluses are in there in terms of moles per liter or molarity. So if you have pure water, you did not put anything in there but just water, obviously you're going to have equal amounts of H plus and OH minus, and this will be neutral, right? Well, what happens if you add in some droplets of hydrochloric acid, which is a strong acid? You're going to add some more H pluses. So what happens is this. If this number goes up, that means you add more acids. This number has to go down in order for this number to stay the same. And of course, this number is a constant, so it cannot change. So what we will do next is we're going to see what happens if we add acids to the beaker of pure water and bases. So I've drawn 3 beakers here. This focus on the middle beaker. This one's neutral, which means you have equal number of H pluses and OH minuses. Okay? That means it'll be 1e negative 7 and 1e negative 7. If it's acidic, that means you have more H pluses. And if it's basic, that means you have more OH minuses. Okay. At all times, this Kw is always going to be 1 times 10 to the negative 14. So if this number has to go up, this number has to go down. Let's do some sample problems. Here, they want to know what H plus is. Here's the formula. They gave us OH minus, so you just plug it in. 1 times 10 to the negative 14 is equal to H plus will be your X. It's missing. OH minus is 0.0025. And X, when you calculate that, will be equal to 4.0. This has 2 sig figs. Kw will have infinite, so that has a lot. 4.0 E or times 10 to the negative 12. This is the amount of H pluses. This is the molarity of H pluses. And this is the molarity of OH minuses. So if I ask you, is the solution acidic, basic, or neutral? Well, this number is 0.0025. This number is negative 12, so 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 molar. So which number is bigger? This number is bigger. That means you have more OHs in the beaker, and now the beaker is going to be basic. Okay? Please do the same on the next problem. Pause your video now. Okay, I got this answer right here. And if I look at it, oh my goodness, is that a big number to you or a small number? That is a very small number because it is to the negative 15. That means 0.1, 2, 3, 4, 14 zeros, and so on, and a 7 and a 7. I didn't do 14 zeros. Okay, but that's really, really small. This number is obviously bigger, which means there are more H pluses, which means this beaker is going to be acidic. Okay, and that's all.